Hello, my name is David, and I'm a representative from Other Planet Skate. Today I'm going to be showing you a little bit about our trucks and what it is about them that makes them different from other trucks out right now. And we use a downhill geometry, which is not dissimilar to that used in downhill specific trucks and setups, which are already out in the market. Really all that means is that the deck is low to the ground, the board is directional with a designated front and rear truck. The front truck is more turny than the rear, allowing the rear to track behind it, which makes the rear truck more stable and less likely to slip or drift during a high-speed turn. The trucks are also going to have a reduced kingpin angle. The kingpin angle is essentially just the angle at which the truck comes up the deck at. Now, a traditional non-downhill specific truck is going to have a kingpin angle right around 50 degrees. A downhill specific setup can have a kingpin angle as low as 30 degrees. However, that's sometimes considered extreme because when you're reducing the kingpin angle, all you're really doing is detuning your truck. So you can achieve more stability, but you're reducing your ability to turn. On this board we have trucks which are set up for downhill. This front truck has a kingpin angle of 40 degrees. This rear truck has a kingpin angle of 50 degrees. The board has a turning radius of just under 15 feet. And on our board here, the front truck has a kingpin angle of 25 degrees, and the rear truck has a kingpin angle of only 15 degrees. However, because of our trucks, we can provide the stability uncompromised. The turning radius of this board is under 12 feet. Because our trucks operate so much differently than others, we can use methods to provide stability that other trucks cannot. Here I have a variety of different trucks and hangers set up, and I'm going to be showing you a little of the mechanics behind them so you can understand a little more about how they work. Here I have a hanger from a Land Yachts Bear truck. At the top you can see it has this pivot. When you turn the board, this hanger will spin around this single pivot point at the top of the hanger. Okay? It's really simple. That's all that's happening, really. The bushings, what they do is they're compressed and they resist this motion. Okay? Here we have one of our very earliest prototypes. Now this truck actually functions on almost identical mechanics to this Land Yachts truck right here. You can see it's got this single pivot point, like that. It's pivoting right there. The pivot axis is directly above the axle. Okay. Same with this one here. Here's the pivot point, and here's the axle right here. You can see it's not quite center. It's above the center of the axle. And now if I could align the pivot axis of these two trucks, you'd be able to see just how similar they actually are in function. See right there? This one pivots like this. This one pivots like this. It's the exact same. These two trucks are equivalent, with the exception that this one has bushing seats. This one has no bushings. Okay? Here I have another prototype. And this is actually where we start changing direction as far as the mechanics of the truck. Here we see there is no center pivot point. Instead there are two. And when you're turning, it'll actually switch between them. It'll pivot on the right, and it'll pivot on the left. No, right, left. Okay. Here is a much more modern prototype of our trucks. You can see it still has the two bolts, and it still seems to pivot in a very similar way. But when I take the trucks apart, you'll see they're actually quite a bit different. Instead of the two bolts, you have this cam. And instead of the pivot point switching between the two bolts, you'll see that it'll actually move from one side to the other as you're turning. Some other important things to know about these cams is that the center of gravity will actually raise as you enter a turn. Also, the shape of the cam will control much about how the board rides and feels. These angles right here control how much deck tip you can get out of the board. This is set right now for 22 degrees. This cam profile will control how fast your board will enter these turns. What I've done here is I've taken the bushings off these trucks and set it up so that all that is happening is the board is rolling on these pivots. You'll find that without the resistance of the bushings, the board will actually fall from center into a turn. This is inherently a very unstable design. Any weight on the deck is going to cause the board to turn unless it is balanced directly over these pivot points. Here I've removed all the resistance from the trucks. Because the center of gravity of the deck will raise as you enter a turn, you'll find that the board will actually drop back to center. This will actually improve the stability of the deck to the point where it's rideable the way it is right now. When you step into a turn, you won't experience the sensation of dropping or falling. Instead, you'll find you have a surprising amount of control without the aid of resistance throughout the full range of motion of the deck. Another benefit of having the deck raised during a turn is the fact that this lower edge will not drop as far down. This means that we can maintain our desired deck tip without sacrificing on deck height. By using this method, we can reduce the height of the deck by nearly ½ an inch. Until recently, our trucks could only be attached to a deck using an end bracket like this. While this system works very well, it would often require that the ends of the board be cut off to accommodate our trucks. Our newest prototype is designed to fix this problem. It uses all the technology of our previous trucks, but fits them underneath the deck using a standard bolt pattern. This allows our trucks to be mounted easily to many decks that are already on the market.